Hello everyone. In this section we're going to talk about a visual aid in trying to assess normality of a set of scores. So remember, in chapter 6 we're talking about the normal distribution. So in this section we would like to know, given a set of scores, how do I determine if this data that I'm working with follows a normal distribution, or it could have possibly come from a population whose scores for the random variable are normally distributed. So that's what we're doing. So let me go to the page of the book where we're going to start, and here's the page of the book. We are on page 278, Assessing Normality. Now, there are different ways we could assess normality. In this course, our primarily concern is visual methods, although there are quantitative methods which can determine whether a set of scores could have come from a normal population. But our method in this section is purely a graphical method. So what we're going to use here in this section to assess normality is what the book calls a normal probability plot. So that's what we're going to look at. Now, a normal probability plot, it's also called a Q-Q plot. So let me go back here again. I'm going to toggle back and forth between my notebook and the page of the book and later StatCrunch. So how are we going to do this? We're going to say that we're going to be using what we call a Q-Q plot. Now the word Q here, or the letter Q here, stands for quantile. So we're going to look at a quantile plot. A quantile plot is actually a plot that divides the data into equal portions. So think of a quantile as a fraction where certain values fall below that quantile. So you already know about some quantiles. For example, median is the 50th percentile, so median is a quantile. All the quartiles we talked about, Q1, Q2, Q3, Q2 being the median, these are all quantiles. So again, what we want to do, let me write our objective here. We want to we would like to test, and again, this is going to be a visual test, not a quantitative test. We'd like to test for normality. That's what we would like to do. Okay, now the Q-Q plot, or the probability plots, could actually compare any two data sets. So it's not just for normality. I could, for example, determine if a set of scores could have come from a uniform distribution or any probability distribution that I'm familiar with. Okay, so again, it's not just for normality, but we're going to use it in this context. So let me go actually to a page of the book again and show you an example of a Q-Q plot here. So in this example, and we're going to the next page, and on top of the page here to the left, right about here, so what this data is about is the author has created a data set. These are adjusted gross incomes based on 12 randomly selected tax returns. Okay, I believe there are 12 scores in here. So the score 7.8 means $7,800, and so on and so forth. So note, if we were to do this, by the way, by hand, which we are not, we're just going to look at the displays and then we're going to go to StatCrunch and do it that way. Although there is a table in the back of the book where you can actually get the normal scores that he has here, depending on the sample size, and you can plot these yourselves, but I'm not even going to show you that. That's not what we want to do. But just the process here. The first thing we need to do, step one, if we were to do this by hand, we need to order the data from low to high, and that's what you see here. Data is ordered from low to high. Now, because there are 12 data points, we need to divide a normal distribution into 13 pieces. And usually it's the sample size plus 1. And then each piece will hold approximately equal percentage, equal quantile. And then from that distribution, we come up with these normal scores. Again, don't worry where these normal scores come from. I'm not even going to go through that. But what's important is what's to the right of that, this figure 623. Now, again, if the data comes from a normal distribution or any distribution, two distributions we're comparing. In this case, we're comparing adjusted gross income to that the normal scores. Okay, so those are the two distributions. Now, if this is true and the data follows a normal distribution, then all the points should fall on a 45-degree angle. It's going to lie into on a line that basically looks like that. Okay. So how are we going to actually do this? Based on what I just said here. So it looks like, based on what I just said, this data does not fall on a straight line, so I can say that this data does not follow a normal distribution, primarily because, see the bending in here, the beta bends. If this part wasn't there, the rest of it looks like pretty linear. So we're going to say that the adjusted gross income does not follow a normal distribution. Now the distribution is actually a bit skewed. And the reason I can say that this is skewed, and it's skewed to the right, in fact, is because of these two scores. If you look at the adjusted gross income, the random variable gross income, you can see the separation here. You have some something that's in the order of $51,000 right in here, 51. That's this score right here. That's $51,000. And then you have a gap between that income of 51,000 and the next two incomes above that are rather distant from it. So this is usually this is what a skewed distribution looks like. So again, we can assess that this data does not follow a normal distribution. Now let me show you another visual on page 281. We're going to take a look at actually another exercise or another example. Let's see, this one deals with chicken consumption in pounds. So here the author again is looking at the data for 17 randomly selected people, and let me show you. You can see the raw data, and I'll read that portion of that exercise or example with you. So there you go. This is what the data is about. These are chicken consumptions for 17 randomly selected people are displayed, and we want to use a normal probability plot for this to see whether the data comes from a normal distribution or not. In other words, is the distribution of chicken consumption normal? So these are the raw data, the raw scores. Now I can go to the next page, and the author actually has used a software like we will be using, maybe StatCrunch, in order to come up with these graphs. So again, don't worry about plotting them by hand. We're not going to do that. Now, something interesting happens to this one. If you look at this one point here, this one point by itself, this chicken consumption is actually 0. So there's one individual in the sample who does not consume chicken. So that, for whatever reason that might be, they could be allergic to chicken, I don't know, or they could be vegetarian, they could be vegan, whatever that the case might be. The point being is that this one individual, this one observation is what we call an outlier, and that's what this is. An outlier, again, in this case, is an observation that is far away from the rest of the group. Now, if you take this outlier out, and that's what the author does in this segment, notice this cluster of data points is the same as the cluster that you see here. The difference is the outlier was removed in part B, and the outlier is kept in part A. So again, leaving this outlier thing out, we can see that the data follows pretty close to that straight line that I was talking about. And there you go. So we can say the amount of chicken consumption follows a normal distribution. Okay, so that's what that is. Now, let's go to some exercises in here, and then what I like to do is I like to go to StatCrunch, and I'm going to actually show you how we can do this in StatCrunch, how we can get these charts in StatCrunch. So I'm going to go to page 283 now, and that's where the beginning of the exercises are. Now, in this exercise, or in these exercises, let's take a look at number 117. The question, simple. He's provided a normal probability plot. Remember, the normal probability plot is also called a Q-Q plot. From a sample of a population. In each case, assess the normality of the variable. Okay, so looking at this one, so you can kind of see there's a clear secular trend in this data. Everything looks good. So yes, this data looks like it could have come from a normal distribution. Now remember, we're looking for a secular trend. That means a linear trend. So I guess we have a consensus that this data could have come from a normal distribution. Now if I look at number 118, this one also does look like it's come from a normal distribution. The one score here could potentially be an outlier. So there's the analysis for this one. And in number 119, now this one, there's a clear bending. You see that one, how it bends here? So this data does not follow a normal distribution, right? Because of the bending that you see here. And if you look at this one, the same effect. You have this bending effect here. This one, it's pretty close to being normal. Was it not for these two maybe scores? It's pretty normal distribution. So we're just going to say that it's approximately normal. Number 120, approximately normal. Number 121, this one, because you actually have it looks like you have a separation. No, one line does not fit this. So for this one, we're going to say it's not normal distribution because we got 1, 2 separate pieces of lines here. And finally, for this data, it's not only has an outlier, you can also see that the data kind of rises. So there's some kind of an exponential effect going on in here. Therefore, this data too does not follow a normal distribution. Okay. Now, we'll do this exercise in a moment. In fact, let me try to do this exercise. We'll do it together. And we'll see how this can be done in StatCrunch. So this is exercise 123. And if I click on this globe, it will actually import this data. And there you go. It goes into StatCrunch. And here's the data that we're looking at for exercise number 123. Now this data is actually a sample of the final exam scores in a large introductory statistics course, as the problem reads. So we want to determine whether the distribution of the scores on the final exam follows a normal distribution. So here's how you do this. Look how easy this is. So we're going to go to graph. Okay. And then scrolling down, going down the list, we're going to go to, there you go, Q-Q plot. That's where we're going to go. We're going to click on the Q-Q plot. And here it says select the random variable. There's only one variable score, so I'm just going to left click once on that. Now, going down here, there's not much you want to change in this pop-up. And the only thing that I would say you want to do is this. Under the other options, make sure you check the normal quantiles on the y-axis. Otherwise, you're not going to get the images, the figures that are in the book, and you're not going to get what's in in My Math Lab. Okay, so in My Math Lab, this thing is checked. So please make sure you check it. Otherwise, the thing would be rotated, the axes would be reversed, and you get confused. Okay, and that's it. Leave everything else alone unless you want to experiment and see what thing could happen. So I'm just going to click on compute, and there you go. See how easy that was? And this is that 45-degree angle line that I was telling you about right there. Now, the distribution of scores on the final exam looks like, for most parts, well, what do you think? So we have this nice cluster that are nearly on the line. Now, just a word of caution here. With real data, seldom you get things that line up exactly on a straight line. I mean, I'll look at an exercise in a few minutes where it nearly does, but very seldom you would expect everything to fall exactly on this red line. So, having said that, it looks like this portion of data, the cluster of data points, follow pretty close to a normal distribution. We have a couple of scores here. Remember the outliers we saw with the chicken consumption? So we have a couple of scores here. This one and this one, namely. These two are potential outliers. Now, if you look at the scores on this one, this student scored 34. Next to that, this other student scored 39. Okay, so both of these are potential outliers. And this is what's causing, because they're on the low end of the scale, you see the separation between these scores and the next group of or cluster of scores. This tells me this data is left skewed. Okay, left skewed. So what determines right or left skewed has to do with extreme values. The separation between low end, if there is a separation on the low end, it's going to be left skewed. If there was a separation on the right end, then it would have been what do you call it? It would have been a right skewed. Okay, now we can, so again, make a long story short, this data almost follows a normal distribution, and there are two potential outliers here. Now let me do this. Let me X this out. I'm going to take these two scores out. Okay, so I'm going to, sorry, I have to bring this keyboard up again. So I'm going to remove this one and the 39 and 34. So let me delete this one also. Maybe right click would do. No, sorry, I gotta use this keyboard again. Back and enter. Okay, so I just removed this one and this one. Now let me redraw that QQ plot. So I'm gonna go to graph, and under graph I'm going to go QQ, and same thing, scores. Make sure you check the normal quantiles on y-axis and compute, and check this out. See the difference there? Now with those two gone, this data follows nearly a normal distribution. Don't worry about the fact that these points sits up slightly above the red line. Again, these deviations are not far from the red line. And of course, you go up here, and if you click, this will actually create a full screen size chart. There you go. So you can kind of see that linearity in the data points better, or you can shrink it back. So again, this here extends the graph, and this will minimize it again. And there you have it. So let me X this out. Okay, so that was the distribution of test scores. Now, let me actually do this just to show you. I'm going to create a right skew distribution. And, oh, before I do, actually, maybe this is better. For this data that we had, remember this was, oh, maybe I can do this. Let me, oh, I can't take things back. Okay. Sorry, so it was 39, 34. Remember, I'm going to put those two scores back on there. One of them was 34, and this one was 39, right? Okay, so we put those two scores back in. Now, I'm going to show you another way that you can check for normality. If you go to your graph, you can actually do a histogram, you can do stem and leaf, you can do box plots. Dot plots don't look that well for small samples, so I'm not going to do that one. But let me do a box plot. Usually we do a box plot or we do a QQ plot to do a visual inspection of normality. So here's a box plot. Click on that and choose the scores, and I'm going to keep everything. I like my boxes horizontal so I can relate to the number line that way better. And compute, and here is the box plot of this one. Now remember, in a box plot for a normal distribution, the box had to be symmetric, so this rectangular box would be more centered here, and the median, the middle line, would be more towards the middle of the rectangle. Now the fact that there is a long whiskers coming out of this box tells me that this distribution is left skewed, and here is a potential outlier. This outlier is that score of 34. So what StatCrunch does, because I had one of the options, let me show you my options, edit. What I had also checked was this option. You see that? Use fences to identify outliers. That was checked. So the software checked for outlier, and 34 was deemed an outlier, and that's why the fences were activated. Let me deactivate this one, and you will see a longer tail now. Compute, and there you go. You see that? This tail, the whisker that comes out of the box, the left whisker, is longer than the right whisker, this whisker. So left is longer than the right, which again points to the same information. We just get a confirmation of what we saw in the QQ plot. And that's how we assess normality. Again, these are visual ways of doing it. There are actually hypothesis tests that we can do. There are quantitative methods that can be used to assess normality. But in this course, we're just looking at these two methods, a box plot and possibly a QQ plot. Now, QQ plots I like because for small samples, they're more meaningful than even box plots. Histograms are absolutely worthless with small samples, so they're not informative. And neither are dot plots or stem and leaves. But box plots and QQ plots. For small samples, my choice is a QQ plot. Now the QQ plot, again, some people call these PP plots, P as in probability, plots, PP plots, or QQ plots. And there, that's what you have here. Now let me do again just one illustration. I'm going to create a right skew distribution and look at the QQ plot of this right skew distribution. So I'm just going to go to data. You don't have to do this. I'm just going above and beyond. So we're done pretty much with this section. I just want to show you something cool. I'm going to go to simulate, and I'm going to go to a beta distribution here, or yeah, let me go to a beta distribution. Rows, I'm just going to create 50 scores here, and these are the numbers, and I'm going to create 50 scores. Let's see, no, invalid number for columns. Okay, I see. So I'm going to put 1 for the columns here. Number of columns is going to be 1, and invalid number for alpha. Okay, I see what's wrong. It's because I'm using the keyboard. I'm going to go alpha 2 here and beta 2. Again, don't worry about what I'm doing here. I'm just defining a distribution here. So I'm just going to go 2, and for this one 2 also. And pretty much that's all I need. And column name, I'm just going to call this one, this is going to be a right skew distribution, so I'm just going to call it right SQ. Okay, and that's what I like to have. And there you go. So I just created these right skew distributions. Now you can actually create several of these if you like. Let me show you what this distribution, by the way, looks like. Just again, just so you've seen it. I'm gonna go, I believe it was beta I did. I changed this to number to 2. And the other number also let's see, oh, 23, sorry. Let me, maybe I should use my keyboard is better. So I'm just gonna, go to here and to here, compute, oops, that's not what I wanted, was it? Let me go 4. Okay, there you go. So that's my skew distribution. In fact, let me change that to an 8. So we see more of a skewness. So there you go. This is the distribution that is skewed to 8. So let me, in fact, rearrange this one. I'm going to go delete the column. And I'm just going to go data simulate beta. Rows, I want 50 columns. I'm going to create 2 columns and I'll tell you why. And I'm just going to go 2 and 8 here. And prefix, I'm just going to call it, this is going to be right SQ distribution, RSK, compute. So I get 2 columns. Both of these data that you're looking at, both of these are right skew distribution. The reason I did 2 of them is because these are generated using random numbers. So sometimes they don't look really that right skewed as you would expect them to. So I'm just going to do 2 and pick the one that's more skewed than the other. So here I go again. Graph. There we go. Graph. And I'm going to go to QQ plot. I'm going to choose select more than one shift click. So I'm just going to click RSK1 and then I'm going to use the control button on the keyboard to select the second one. And I want normal quantiles on the y-axis. And right down here, I just want to have columns per page. I'm going to go 2 columns, and the reason because I want 2 QQ plots on the same graph. And there you go. Now, this data is more skewed to the right than this one, isn't it, folks? And the reason is this. Look at the separation between the raw scores. So the scores here, it's about 0.4. Right, just shy of 0.4 to 0.7, so they're further apart, so that means it's skewed to the right. And this one is also skewed to the right, but not as skewed as this one is. And again, for this chunk of it, looks like the data is approximately normal over the cluster here and over the cluster here. But all in all, because of the way you see this is bending, we're going to say that data does not follow a normal distribution. Okay, now we're going to end this by just looking at one example. Let me go to the book and we're going to look at one example of how in practice this data could actually follow a normal distribution. And we're going to take a look at exercise number 131. This would be on page 284. And here's exercise number 131, body temperature. So for this exercise, what they've done, I mean, you can read it. This is the actual body temperature of 93 healthy humans. Okay. Now the theory says, by the way, our body temperature on average should be about 98.6 degrees Fahrenheit. So we just want to look at this 93 healthy humans, and we want to know whether this data follows a normal distribution. He's asking us to obtain a histogram and also a normal probability plot, or the QQ plot. So let's see, this is exercise 131. I'm actually going to use a box plot. So I'm going to use a box plot and a QQ plot. So here are the raw scores. Now look at this data. Most of them pretty close to 98 degrees Fahrenheit. So I'm going to go graph. First, I'm going to do a box plot. The box plot of temperature drawn horizontally and compute. And there is the box plot. You see how nice, almost symmetric. Look at the right, the left whiskers are almost the same size, right? The distance from here to here is almost the same as the distance coming from the third quartile to the maximum. And that middle line, which is the median body temperature, is 98.2, right? You can read it on the screen. It's 98.2, right? And so it looks like this data is approximately normal. So the body temperature of healthy humans is approximately normally distributed with a mean of 98.2 2 in this case, but again, the theory says 98.6. Now, let's do a QQ plot, and this is going to come out to be interesting. So I'm going to go to QQ plot, and then here's click on temp, and normal quantiles on the y-axis, and compute. There you go. So you see how nicely everything fits almost right on that. Let me extend this. You see that again, the 45-degree angle line right in here, and all of these body temperatures pretty much fall on there. Now, although these may seem away, but these deviations are not that much. We're talking like 0.2 degrees Fahrenheit from 98.6. Okay, so there you have it. A good example of what in practice a normal distribution could look like. And that is all we wanted to do in this section. So I wasn't able to write much here, was I? Because again, what we do is primarily in StatCrunch. So with that, we are done with this section, and we're done with chapter 6. After this, we're going to move on to chapter 7. So that's all from this lecture.